Calculus Kids, this is Dr. Callahan with week 14 Thursday. How are you guys doing? Go ahead and pause the video and answer the following 3 questions for your warm-up log. All right, let's go ahead and get started with today's stuff. So looking at this right here, you should have the following items. Here is page 1 on week 14 Thursdays guided notes, page 2, page 3, page 4, and page 5, which I will be passing this out to you guys in class. And these are, or this is the free response question that was featured on the 2018 question number 2 for the free response with a calculator. So let's go ahead and get started. I'm gonna have you guys go ahead and get started on this part right here. So with a highlighter, go ahead and read and highlight some of the tips from the AP exam from College Board. My comments are added in the parentheses, so go ahead and highlight them. Afterwards, you do have other helpful tips and suggestions just because. Okay, on the right side are several concepts that I feel you guys need to understand or relearn. So you have the first 4 right here, along with 5 to 12 over here, and the next 6 right here on the left side. On the right, I do have some additional tips for study tips when it comes to the AP exam. Oh, that is a little bit loud, so I'm going to go ahead and turn this down just a little bit. Okay, so then take a look over here for week 14 Thursday. Now, actually, I'm not going to look at that one. We're going to skip the last one that I just suggested. That's okay, though. All right, next one I need is your email addresses. So you can either type in this tiny URL or use this QR code. Find your name on the very bottom and then type in your email address so that way I can get a hold of you during the next couple of weeks. And then with that said, we're going to go ahead and get started on this question. So pause the video, take a moment, and make sure you understand the question it's asking. All right, so a particle is moving along the x-axis. It's given to you that you have the velocity. So already I'm thinking, okay, position function derivative give me velocity. The first derivative velocity gives me acceleration. So I'm not even sure it's asking for acceleration, but I know that's what I have. And it's given by this v of t equation with a trig function of sine between 0 and 3.5. And 3.5, is this minutes? Is this seconds? Does it even tell me? I don't think it does. I don't think it actually mentioned if it's seconds or minutes or whatever, or hours. But that's okay. We'll just 3.5. And so let's go ahead and take a look at part A. A says find the acceleration of the particle when t is equal to 3. So you know you're looking at this from v of t's perspective. So you're going to need your calculator. So you're going to use your TI 84. You're going to click on math and then 9 and, or I'm sorry, not 9, 8, which is derivative. Okay. And you're essentially just going to plug in v prime of 3 point, or so no, not 3.5, just 3. Just 3. And that's my little girl saying hi. V prime of 3. And you're going to type in 10 sine 0.4 times 3 squared, which is going to be 9, all the way over 9 minus 3 plus 3. So essentially this is just 9. And you're going to go ahead and figure out what that is going to be. So you can either do that with a derivative or you can go ahead and use that with a calculator. So a of 3 is equal to v prime of 3, which is equal to negative 2.118. And this is going to be, I don't think it gives me any units, so there's really nothing that I can do besides just write that. So I like to include a little bit more, but in this situation, it's not happening. Okay, let's go on to B. So for B, it says find the position of the particle when it's t equals 3. The keyword here is position, so you're looking for the s of t, which is the position function. The position function is going to be equal to the integral of v of t. So we're going to do the integral in this situation. So we are going to say s of t is equal to, this position is starting at -5, so -5 plus the integral in between 0 to 3, because it's at t equals 3, so from 0 to 3, v of t dt. So then in your calculator, you're going to hit TI-84 math 9, not 8, because you're dealing with integration here. And you're going to put in 0, 3, and then in the box here, you're going to put in the 10 and type in sine 0.4 t squared divided by t squared minus t plus 3 dt. But in this case, it's going to be dx in your calculator. And whatever you get from here, make sure you subtract the 5 with it. And then your overall answer for S of 3 is going to be a -1.760. So with this one, you can actually say the position at t equals 3 is -1.760. Okay, let's go on to C. For C, it says evaluate this from 0 to 3.5. So what you're going to do is we're going to go ahead and just type in with your TI-84 again, math 9, 0 to 3.5, type in the 10 sine 0.4 t squared over t squared minus t plus 3 dt or dx. Once you plug that into your calculator, you should have a 2.844. Now, it's also asking you to evaluate the second piece right here, which is with the absolute value. So you're going to go ahead and make sure you insert the absolute value, and the absolute value symbol is under math. You'll be able to see it. I think it's 3 or something, but push that and take a look at it. But if you do find the integral from 0 to 3.5 of the absolute value of v of t dt, that is going to equal to 3.737. And so your response for this situation could be the particle's displacement on t equals 0 and t equals 3.5 is 2.844. And what that means is that the particle is 2.844 units, because I don't know what the units are, to the right of where the particle stopped. Now, the absolute value of this number here, what that represents is the particle's distance traveled on t equals 0 and t equals 3.5 is 3.737 units. So that is part C. Okay, so for part D, it says a second particle moves along the x-axis with position given by this in between 0 and 3.5. At what time are the two particles moving with the same velocity? So we're going to go ahead and perhaps set them equal to each other. So your second particle, so I'm just going to put that as x up 2, t is equal to t squared minus t. your first particle is given to you, a v of t, so velocity. This right here is a position function, so you need to convert it to velocity, which means you would have to find the first derivative of that. So the first derivative of t squared is 2t minus 1. And so then we're going to go ahead and take this part and then set it equal to the v of t of the first particle, which is 10 sine 0.4 t squared minus t plus 3. Now, there are two different ways that you can go ahead and approach this. I would suggest that you go to y1 into the graph section of it. Make sure you graph y1 and y2 of both of these equations, and then click on the second calc and then intersection button to see where the two graphs intersects. And the time should be about 1.571. So in this way, at what time are the two particles moving with the same velocity? You could say the two particles, and a lot of times it's just a repeat of the question. The two particles are moving with the same velocity at t equals 1.571. And that's what you can write. All right, you guys. So now what I want you guys to do is take a look at the breakdown of the grades. And again, it's out of 9 points. So keep that in mind. And this is just kind of a tally of what, it's just a tally of some of the scores and breakdowns of back in 2018, in addition to the score breakdowns of 2012 to 2020 with the score of 5, 4, 3, 2, 1. So I have a few questions I would like you guys to kind of fill out on these questions. And then when you are done, I want you guys to go ahead and go onto this link and read this article on how the AP test is graded and how do they curve the AP test. Next, I want you guys to use the second page of week 14 Wednesday. And yes, I know that today it is not Wednesday, it's Thursday. But I want you guys to take a look at the multiple choice section with a no calculator and the multiple choice section with the calculator. Look at the level of difficulties and then list 3 similarities and 3 differences on how they are different. All right, you guys, I think that is about it. I hope you have a wonderful week, and I'll see you guys next time. Take care.